Okay, so let's talk about De Morgan's law. So De Morgan's law says two things. The first thing it says is that the negation of an and statement is logically equivalent to the or statement in which each component is negated. So this is what that looks like. The negation of P and Q, in parentheses, is logically equivalent to the negation of P or the negation of Q. The second thing De Morgan's law says is the negation of an or statement is logically equivalent to the and statement in which each component is negated. And this is what that looks like. The negation of P or Q is logically equivalent to the negation of P and the negation of Q. Alright, so the first question says, use De Morgan's law to write negations for the statements in the following problems. So number 25 says, Hal is a math major and Hal's sister is a computer science major. So let's remember what De Morgan's law says. De Morgan's law says that if we have P and Q, then the negation of that is logically equivalent to the negation of P or the negation of Q. And one way you can remember De Morgan's law is you think of it as flipping the sign in the middle so the and becomes an or, and then you kind of distribute the negation to the statement variables. It's just a trick to remember the formula. It's not literally distributing the negation symbols. It's just a trick to remember. Likewise, the negation of P or Q is logically equivalent to the negation of P, and this time you flip the sign and it becomes an and then the negation of Q. So for number 25, Hal is a math major and Hal's sister is a computer science major. Hal is a math major can be P, and Hal's sister is a computer science major can be Q. And since we're trying to take the negation of this whole statement, we would use the first one, the first law, since we're dealing with P and Q. So if we want to write a logically equivalent statement, we would take the negation of P, so Hal is not a math major. Or Hal's sister is not a computer science major. Because remember, we want to take the negation of Q. In this case, Q is this, and the opposite of that would be Hal's sister is not a computer science major. So that's number 25. Okay, let's do number 26 now. 26 says, Sam is an orange belt and Kate is a red belt. So again, De Morgan's law says not P and Q is logically equivalent to not P or not Q. And in this case, Sam is an orange belt is P, Kate is a red belt is Q, and we're using the law with the and symbol since it says and right here. And the negation of this whole statement would be logically equivalent to the negation of P, so Sam is not an orange belt, or Kate is not a red belt. And that is number 26. This statement right here, Sam is an orange belt and Kate is a red belt. Negation of this statement is the same thing as this statement right here. Okay, number 27 says the connector is loose or the machine is unplugged. So remember that De Morgan's law says the negation of P or Q is logically equivalent to the negation of P and the negation of Q. And so the connector is loose right here would be P, and the machine is unplugged would be Q. And we're dealing with or, so that's why we're using this law. And so if you want to take the negation of this, that is logically equivalent to the negation of P, so the connector is not loose. And negation of Q, which is the machine is not unclogged. So again, this sentence right here, the negation of it is logically equivalent to this sentence. Number 29 says, this computer program has a logical error in the first 10 lines, or it is being run with an incomplete data set. So we see that the sentence has an or in it, and it's connecting two statements together with an or, so we're going to use the law that has the or symbol. So negation of P or Q is logically equivalent to the negation of P and the negation of Q. In this case, P would be this computer statement has a logical error in the first 10 lines, that's P, and then it is being run with an incomplete data set is Q. So if we want to take the negation of this whole sentence, we could write the logical equivalent sentence, which is negation of P, so the computer program, or this computer program, does not have a logical in the first 10 lines, and it is not being run with an incomplete, it's not being run with an data set. Alright, so this question says, assume x is a particular real number and use De Morgan's laws to write negations for the following statements. So number 32 says, -2 is less than x, and x is less than 7. This is the same thing as saying -2 is less than x, and x is less than 7. We know that De Morgan's law says, one of De Morgan's laws say that the negation of P and Q is logically equivalent to negation of P or the negation of Q. So we could say this right here is P, and this right here is Q. If we want to take the negation of this, we take the negation of P first. And how you do that is, you flip the sign, and if there is no line at the bottom, you put a line there. And then that's the negation of P. This is the negation of P. So -2 is less than x. The negation of that is -2 is greater than or equal to x. The opposite of and is or. So you can see right here, and becomes an or. And then we take the negation of Q. So again, flip the sign, and if there's a line there, you don't put a line. But if there is no line, then you do put a line, which is the case here, and then ta-da, you have the negation of this guy. Okay, number 34 says x is less than 2 or x is greater than 5. One of De Morgan's laws say that the negation of P or Q is logically equivalent to the negation of P and the negation of Q. So we have P, which is x less than 2, and Q, which is x is greater than 5. And the negation of P is x is greater than or equal to 2. Remember, you flip the sign, and then you put a bar there if there is no bar here. The or becomes an and then the negation of Q is x is less than or equal to 5. You flip the sign, and you add a bar if there's no bar here. and you could combine these two together so that it looks like this. And there you have the negation of this guy, which is this. Okay, number 36 says 1 is greater than x, and x is greater than or equal to -3. That's the same thing as saying 1 is greater than x, and x is greater than or equal to -3. And we know that one of De Morgan's laws says the negation of P and Q, oopsies, P and Q is logically equivalent to the negation of P or the negation of Q. And so this is going to be P, this is going to be Q. The negation of P is 1 is less than or equal to x. You flip the sign, you add a bar at the bottom, and then the and becomes an or. And then the negation of Q is you flip the sign. However, there's a bar here, so there's no bar here. And so x is greater than or equal to -3. The negation of that is x is less than -3. This right here is the negation of this statement. So this question says, imagine that num orders and num in stock are particular values, such as might occur during execution of a computer program. Write negations for the following statements. So num orders is greater than 100, and num in stock is less than or equal to 500, or num in stock is less than 200. So let's break that down. So at first glance, we can see that this right here could be P and this right here could be Q because it's connected by an or and they're both separate statements. So I labeled this P and I labeled this Q. We know that the negation of P or Q is logically equivalent to the negation of P and the negation of Q. So we want to take the negation of P first. You can see this statement has some statements within it. So let's focus on that. So let's call this statement P2 and this statement Q2. You know that the negation of P2 and Q2 is logically equivalent to the negation of P2 or the negation of Q2. So the negation of P2 would be num orders is less than or equal to 100. Remember, you flip the sign and you add a bar, there isn't one here. And then make the and turn to an or, and take the negation of this guy. So you flip the sign, and since there's a bar here, there's no bar here. So this right here is the negation of P. Remember that this is an or, so we have to write and. Now we'll put parentheses right here just to separate it from this section. So the negation of Q would be num in stock is greater than or equal to 200. And you flip the sign, and then you add a bar here. There's no bar here. And that's it. That's your negation of this statement. Remember what we did was we took the De Morgan's law of this whole statement, but in order to do that we have to take the negation of this nested statement, and we have to use De Morgan's law to do that, and that's how we got this whole sentence right here, or this statement right here. Question number 39 says, num orders is less than 50, and num in stock is greater than 300, or 50 is less than or equal to num orders, which is less than 75, and num in stock is greater than 500. So as you can see here, there's this statement or this statement. So this right here could be P, and this right here could be Q. We know that the negation of P or Q is logically equivalent to the negation of P and the negation of Q. So we have to take the negation of P. And this right here is a nested statement. So this statement will require De Morgan's law. So we know that the negation of, let's call it P2, and Q2 is logically equivalent to the negation of P2 or the negation of Q2. So P2 in this case is num orders less than 50, and num in stock is greater than 300 will be Q2. So let's take the negation of P2. So num orders less than 50, the negation of that would be num orders is greater than or equal to 50, or num in stock is less than or equal to 300. And what I did was I just flipped the sign, and then I put a bar underneath it because there are no bars here. So that is the negation of P, because we took the negation of this whole statement, which is P. So then we write the opposite of or, which is and. And then now we have to take the negation of Q. So let's call this P3, and this right here Q3, and then we can just change numbers to 3 this time. So P3 is actually another nested statement that we'll have to do, because 50 is less than or equal to num orders, which is less than 75. The same thing as saying 50 is less than or equal to num orders, and num orders is less than 75. And so in order to take the negation of this statement, take the negation of this guy. So 50 is greater than num orders, or num orders is greater than or equal to 75. And so that is the negation of P3. So we can write that down here. So 50 is less than num orders, or num orders is greater than or equal to 75. And then the opposite of and is or. And then we have to take the negation of Q3, which is num in stock is less than or equal to 500. And so this is the negation of this whole statement up here.